Hello.
Yeah.
Am I audible?
Yeah.
Hello. Am I
Yeah.
audible? Sorry for the delay, ma'am.
Yeah.
Hello. So,
Yeah.
yeah, for the delay, to start, ma'am. So, we'll have a small introduction, ma'am.
Yeah.
This session to an student.
Hi, ma'am. Am I audible?
Yeah. Fine.
When we share knowledge, we unlock infinite potential. What begins as a simple idea can evolve into a transformative force, changing lives and shaping the future. Myself, Akshaya, yet again back with another spectacular keynote session. Now, it is my honor to introduce our esteemed keynote speaker for today, Dr. S.N. Deepa. Currently, Dr. Deepa is an associate professor in the Department of Electrical Engineering at NIT Calicut with 21 years of teaching and research experience. Her prolific academic career includes the publication of 10 books, 105 international journal papers, and 57 conference papers, along with an Indian patent granted and 2 patents filed and published. She has been recognized with numerous awards, including a national award from ISTE and LNT for her ME thesis, and her PhD was fully funded under the National Doctoral Fellowship Scheme by AICTE. Under her mentorship, 25 scholars have completed their PhD
Yeah.
programs, and
Hello.
she's currently
So,
Yeah.
guiding 4 more scholars. Dr. Deepa's research spans machine learning, deep learning applications in controller design, renewable energy, medical image processing, and control system optimization. Her exceptional research impact includes over 10,760 citations, a Google Scholar Hedge Index of 26, and numerous other work. We are truly fortunate to have you here. Share your insights with us, ma'am, today.
Yeah.
Please join me in extending a virtual welcome to Dr. S.N. Deepa. Over to you, ma'am.
Yeah, thank you. Thank you for the introduction. A very good afternoon to all the delegates, participants, and esteemed guests, and the organizing team of this conference, the most relevant conference of the day, International Conference of Intelligent and Sustainable Power and Energy Systems. So, intelligent one side, sustainability, moving towards our goal of all our sustainable goals of vision of our nation. So I think this is an apt title for the conference, Net Zero to be achieved in 2070. So sustainability is highly everywhere. So everywhere it is to be green campus, sustainability, the smart cities, etc. The project goes on. So I think so. Since it is intelligent, I thought when Dr. Sujit was discussing with me, I thought I have worked few of my scholars, and I have personally worked on predictive models for this renewable energy sector. I thought in Keynote, see Keynote, it's not like a workshop or like an FDP or I can take long elaborately. So since it's a Keynote speech, I thought to what level I could detail it, I will present it. Let me share my slides. Yeah, I think my slides are visible, right? Uh,
Yes, ma'am.
yeah, yeah. So, see, presently to speak about the renewable energy capacity in India. So this data was taken with respect to March 2024. We were submitting a proposal for Smart India. To a funding agency. So at the time during March, this data was taken. So if you look into this data, so the renewable energy capacity of India with respect to wind power makes to about 45.88 percentage. If you see large hydro comes to about 46.92%, and solar power takes more even than this hydro, and if you see wind 81.81%. See, the remaining comes your small hydropower, your biomass or waste to energy. So if you see this yellow, dark green and the light green, the solar on one side, the wind on another side, the large hydros, see the large hydros, I think how many plants, because I have experience in Arunachal Pradesh. I visited several hydro plants when I was working earlier, prior to NIT Calicut, I was with NIT Arunachal Pradesh. I have visited several, we had several consultancy with this hydro projects actually, so I was to visit several hydro installations at complete northeast. During my travel, we have observed initial installation is fine, but without maintaining, see for example, there are nearly 56 plants, okay, large hydro plants in Arunachal itself. But if you see the currently operating fully successful to meet the demand is only 12. See, remaining 40 to 50 are idle actually. Okay, so this is a pathetic condition because I witnessed it. So even though large hydro, we focus on that. If you see whether for the required power requirement, even though we have installed with so much cost, a large hydro has been implemented, designed, and is operational. If you see, it is not producing. Why? Maintenance, because we lack people for maintenance at the hydro plants located, and hence is the again further installation, further establishment of these plants, of these hydro plants even in Arunachal, because since I was in the field, I know this exact situation. So because of the maintenance, this happens to be the problem. So whenever you go for renewable energy establish, if you see solar, see 81.81. See the solar is highest. See, it depends upon the irradiance level. It depends on the irradiance level of from the sun. Yes, so the radiance, the solar power, or the irradiance which will be reflected on the panel. So if you see, the first sunrise in India is also at Arunachal Pradesh. So early morning sometimes 4:30 will be like 7:30 in a normal state. Okay. So I was there for 3.5 years. So if you see, I am telling morning 4:30 sunrise. Okay, so morning the first sunrise point of India is Arunachal Pradesh, and the first one that state only will be witnessing the sun. So hence what happens? So the for 4:30 the brightness, okay, or the intensity of the radiations will be like, what to say? It will be like 7:30. If normal in Tamil Nadu or in Kerala, that heat of the sun can be between only 7:15. For example, to 8:15 or 9:15 radiation. So I don't know about the Karnataka. I have not felt that intensity in that early morning for a long duration of time. So hence what I'm telling is, so hence from 4:30 onwards till even 2:30, the radiation or the sun intensity is very high in Arunachal. So hence solar has a high scope. So what I'm meaning to say, everywhere, see 81.81. So if you see Gujarat also, if you see many plants are there. Okay, so Ahmedabad or wherever, if it is going to be Surat or whatever it is, you have many large plants which is producing a few good amount of megawatts is in Gujarat or something. So Arunachal also, if you see, many solar installations are highly productive and it meets the power demand actually. See, apart from that, so next part, if you see, 45.88% of that is being produced by the wind power. So if you see wind, Tamil Nadu is one of the best example of wind. So I have been in contact with Suzlon Wind Energy, ZF Wind Power. I've been in contact with National Institute of Wind Energy. So if anyone who want to operate with renewable energy on wind or solar, so if you want to operate on wind, for example, you please be in touch with NIWE. Okay, so National Institute of Wind Energy, all comes under MNRE, all are autonomous bodies basically actually. So if you see, on the other hand, along with NIWE, you can be in contact with NISE, National Institute of Solar Energy, or typical perfect government organizations where they're really doing good. So they have their own autonomous directors, and they will share all data with respect to solar also. Wherever the plant is, you want to operate on some intelligent model. So I'll come to that part later. So these are most important to with respect to wind and solar. These autonomous bodies will help you. So hence, if you take wind power, so I thought I will explain predictive model of wind and discussed in this keynote session. So if you see in this case, if it is going to be wind, so wind speed is most required. Okay, so if you see in Coimbatore belt, if you see there are Tuticoarins. Okay, so or in Arcot district, or if you see even in Coimbatore district, so even in Coimbatore district, if you see there is a zone called Paladam zone. If you see it is few 32 meters per second. So sometimes the speed of the wind goes so high, even sometimes to 37 or 41.5 or something. So it depends upon the wind speed. So with respect to wind speed, the blades rotate. That is a common mechanism. So hence, see, an initial investment. See, for example, in wind, if I want to locate, textile mills are there. So when textile mills or some groups, oil and natural gas, ONGC, or some Hindustan Petroleum, so because of their electricity bill consumption, they want to become get a subsidy, for example, and they want to have their own wind energy installation. When they want to have wind energy installations on their own, so it will nearly cost around 90 lakhs to 1 CR. Okay, so 1 crore, basically one wind a tunnel with all the blades, with all the turbine mechanisms. So it will cost, but everywhere installation. So this is being bought by many, even like textile mills. If you see, like Vardhaman Textiles. Okay, so Vardhaman's Textiles, it is located in Bhopal also. It has in plants, I think, even in Noida also it has. So if you see Vardhaman Textiles, these people want so much windmills, because their what to say, their what is EB, their electricity bill is so heavy. So hence they want to generate the power, and they want to tell we are producing the power, and that power will be reduced in our electricity bill. So hence what happens, see now though, where to establish the wind plant, where to establish the wind plant. Now though, since solar is common, and with all our Yojana, Solar Yojana, Prime Ministers, all this, many schemes have come. So even we are establishing, for example, we are establishing presently 800 kilowatt. Okay, 800 kilowatt plus an additional of 400 is also given. Okay, so our NIT Calicut. Okay, so our power demand is, for example, 1246 kilowatt, 1.2 megawatt actually. Our institutes, for example, it is 1246, for example. And now too we have started under the scheme. Okay, so under with respect to the solar scheme, now too we have gone for solar rooftop installations. And see, we are locating so many buildings are there, mega hostel, boys, ladies hostel, architecture building, management building, academic building, rooftops. So we are analyzing which place to place the panels, which place the irradiance level will be there. No shadow area should not be there. Okay, there should be no shadow. So partial shading is there, or full shading is there. So we are making so much brainstormings actually. We visit, we take, so we try to take even the weather data. We try to take even the weather data, meteorological data also. So we'll see where which building has more sun brightness capacity, and we have worked on a proposal. And even last week only our tender has been bidding happened actually. So why I'm telling is, see, identifying buildings has been a task. Okay, so we were together to identify which building. See, because we know the sun is there, we don't know about the irradiance level. So the irradiance level, when the intensity will be high, see one plant you are establishing. So if you see for this, for example, for installation of this 1200 kilowatt, for example, it is going to incur nearly 4.5 crores. Okay, so this installation. Okay, so we'll take, I'm telling the minimum cost, so it will take, so 1200 kilowatt if I want to establish. So for example, 1 kilowatt, okay, so divided by that ratio will give you how much you require for solar power generation of a 1 kilowatt. So now to for 1200 kilowatt, so we are expecting between 4.5 crores to 5 crores established. So I cannot just go and put, my investment is so heavy. When my investment is going to be so heavy, I cannot just place it in somewhere where the sun intensity or the irradiance is not proper. This is with respect to solar energy. Now, to with respect to wind energy, if you see, I want to place the tunnel. I want to place the tunnel. So I want to place your wind tunnel. Okay, so I cannot place this wind tunnel somewhere where the wind speed is not there. So because the investment is one tunnel will cost to me about an approximate of 1 crore. So hence it is always, so these energy people, these energy sector or the energy team, whoever you call renewable energy sector, always your MNRE, Ministry of New Renewable Energy Power of India. So ministry will be always focusing on where to establish the, it should, losses should be very much minimal. Okay, see I want, see I'm expecting 1200 kilowatt out of my 4.5 crore rooftop solar installation. I cannot compromise. I want 1200 kilowatt power. Okay, plus or minus 20 kilowatt or plus or minus 18 kilowatt. Okay, so 1200 minus 18 kilowatt might be, or 15 kilowatt might be my eligible limit. So I want this power. So hence always identifying the location, identifying the places for installations of these renewable energy is always a challenge, and it always has to be this, so that for the investment made, the expected power demand has to be met. See, in India, so if you see, I don't know how many are watching this energy news with respect to May 30, our Indian power demand was 250 gigawatt, which was the highest. See, earlier it was one day, I am telling one day, per day, per day, per day, our India's power requirement. This is very, very highest. Okay, so if you see 250 gigawatt, see whether we have installation, see fossil fuels, your coal, your lignite, etc. So how much it is producing, all this renewable. See, power is not decreasing day by day. The requirement of power day by day in ACs, oil depletion. Why though we are speaking about carbon zero, etc. So net carbon zero. Why all this sustainable goals? So India sustainable goals comes into picture means because day by day, see 250 gigawatt per day is our India's requirement. It is not small, my dear participants. It's very huge. Okay, so how we are meeting this power requirement? So if you see, we have to see, so tons and tons of fossil fuels are being burnt, okay, which results to carbon emissions. See, by 2030, the goal, so the ministry's goal, or the power people goal, is to reduce 1 billion tons of carbon emission by 2030, and also we have to reduce the carbon intensity. Otherwise, see, otherwise it's going to be very hectic. So like Delhi, we have the problems of all this breathing, so all emissions, fuel emissions even through vehicles, etc. Many things cause this, and we have to be carbon neutral by 2070. So if you see cumulative install renewable energy capacity, I have shown the pie chart as well. Here I thought I will describe you how much it is being produced by means of this fossil fuels as well. So if you see, so 237 megawatt. So if you see on the other hand, total renewable energy sources will be 179322 megawatts, and the percentage share goes to about 56.8 of the fossil fuels. And this, so all this data and statistics are taken from MNRE website. Okay, the source for all this is from that. So if you see, So renewable energy. So if you see with respect to, so the Rajasthan is producing that, each state has their own. It depends. See, for example, some state will have. See, Arunachal will have larger hydro, larger solar, but they will not have wind. Okay, so the wind is very difficult for installation. So if you see, even in Kerala now, though, our solar is very good. Our solar is very good, and few hydro plants are there. Okay, so some near Ernakulam district or somewhere we have some hydro installation, but wind very difficult in North Kerala. So presently we are located in North Kerala. So only one somewhere one what to say, one government guest house sort of thing, they wanted at least to have a windmill, and that was constructed, and our team of NIT Calicut also were one of the part doing the turbine design for that. So few other people, I was not in the team actually. So like this, so it is based on this Tamil Nadu. So each state will have their own what to say, their own ways of each state will have based on their capacity, whether it is wind, whether it is solar, whether it is biomass, etc. It will be. So hence at this juncture, I wanted to make you what to say. I am throwing a light. So hence, always very important thing is where to locate the windmill. Where to locate the site location. So the site location is very important, and even for solar. Where, see, for example, in our house also, in our home, we have a home on top we can have, but see, when it is going to be larger installations, in order to meet the required one day power demand of our country, in that case, I should not have any losses. If I am estimating I want to produce 1 megawatt from this solar rooftop installation, I need at least 98 megawatt to be sorry. So what to say? So like 0.98 to be produced. Okay, so like I cannot have so much losses in that. So hence what, so one of my scholar, what she was working on was, in for both the cases with respect to solar energy and wind energy. So we were into development of predictive models. So we were into development of predictive models. So intelligent predictive models. So with the growth of, so this was all, we are working more than a decade in this. We have several papers, and we have customized it even like a calculator. If you give wind speed, if you give the temperature, if you give the, what to say, if you give that earlier it had dewness, humidity, etc. So like how, if we give our height, if we give our weight, it will give you our body mass index. Okay, so like that we had so much calculations with that, so much predictive models was done, and even always still NIWE, okay, still NIWE wants better predictive models. So why do we are working on predictive models? Because I cannot simply go and invest 1 crore in a place if the site location is not proper, and if I am not going to get the required amount of energy. So hence is the development of these predictive models. See, predictive models. See, you can use machine learning models. See, you can use. So we have tried with ML models. We have tried with neural network models. So now, though some cases, even see deep learning, even though it is widely used only for images, but with respect to data, because these are going to be time series data models. If it is going to be time series, multi-step wind speed predicting, multi-step. So each step, when the plant is going to be high in one location, if we are going to have 100 installations, for example, then each time step is very important. So you can fix the time step 1 minute, 1 minute ahead, 2 minute ahead, 60 minute ahead, 1 hour ahead, 3 hour ahead. So like this, you can set multi step, and if yours is with respect to time, then the problem will be coming under the scenario of time series forecasting models. So when it is going to be time series data, the data whatever, let be the data, If it is going to be in time series data, then you can go for recurrent deep learning models. Okay, so we are just working on that, because getting time series data from National Institute of Wind Energy or from the OEMs. Okay, so there are some open-ended manufacturers, all OEMs. We have to get the real-time data from the plant, from OEMs. Okay, so even National Institute of Wind Energy is selling the data. You can give cost. See, few data are available in their website which is free of cost. Or if you want data, okay, so if you want data, I want so much entire India solar data I want, yes, you can get it. You have to pay money to National Institute of Solar Energy. So here also there is some money, like this data, if you want rupees 3,200, like that we pay, and we try to get the data from NIWE. So at this juncture, the growth and the importance of these predictive models. So why you require the predictive models? Because renewable energy installation deserves cost, and all over the companies who wants to invest, or even the government can't simply fund, right? So it is so much audits are there. Why? Because once installing, if it is not proper, you have so much audit objections, etc. will come. So you have to make a what is it? You have to make a perfect study analysis. You have to make predictions, and that predictions will confirm you, okay, this is a suitable site for development of all this. Okay, so hence is the growth, and hence is the need of predictive models in renewable energy sector. Either it is going to be, so now though I have worked long with wind and solar, now though I have started working with hydrogen, but getting hydrogen data is very Herculean task, and we have collected few data, very few data, only 800 data has been collected. Okay, so if you see wind and solar, we have millions of data. So pertaining to time, we have access to so much data. But hydrogen, because now the hydrogen is also becoming very green hydrogen mission. Okay, if you see green hydrogen mission is going, so hence we have started for developing predictive models for hydrogen as well. So the hydrogen being produced by electrolysis process. So there are various methods of this solar hydro electrolysis. So if you want your renewable energy, so electrolysis not being done by means of the process of electrolysis, without doing it by means of conventional from your grid, you can go in for solar electrolysis, and that is another part. So I am telling importance of predictive models, because hydrogen is also very expensive. It's very expensive, and storing hydrogen is also very, because otherwise it will become a bomb. Okay, it's an atom bomb basically, hydrogen. If you don't store it properly, so what will happen is it will explode. So hence producing hydrogen, okay, after that, if it is produced, I have to make it extracted properly, and I have to what to say, store it in cylinders. So it can be in solid form, liquid form, gaseous form. So we are studying. So for the past 1 year we are working with hydrogen. So hence I'm telling, so how, in what form to store is also is a big question. Whether it will be in solid form, also some liquid forms. There are so many processes which is being going on. So hence in all these aspects, so one can work on. So if you're interested, if I want to develop some intelligent models, so I have access to data. See, data is predominant here. If you don't have data, see, if you can work, wind means renewable energy. Why, madam, you are telling only on predictive models? I want to work on turbines. Said yes, good. See, whichever is your focus area, whichever is your focus area, you want to work, improve the turbine, improve it, more power to be that in that angle. If you want to work on the aerodynamics of the blades. Okay, so there are civil in our campus. We have some civil team who are working on the blade structure, and they said now though for wind, instead of having all this, there is pulse technology. So only one, so the tunnel will be only like this. You will have only one like this pulse technology, only one blade. Only one blade will be standing, and it uses something called pulse technology. No blades, no rotation. I don't know whether that's single blade. So but I have heard of. I have not explored this, but someone interested can explore this as well. So there is a concept of pulse technology wherein there is no the concept of this three blades or not. So only one a single will be there, and using this technology, this can be carried out. So hence in all these cases, whether it is wind, whether it is solar, whether it is hydrogen, in all these cases, so it is highly important to have a prediction analysis. Okay, so prediction. So if here, if the wind speed is like this, if the temperature is like this, if the dew point is like this, if the humidity is like this, okay, it is a best site. Okay, if it is a best site for performing, for having a wind. So a supplier is coming to you, you have this app or something, you have your calculator or you have your app like this. So like how meteorological data, whether rain will come or not, you put all data, you will get yes, rain will come or not. So like that, an app, so an app sort of thing, or even a calculator, or even a predictive model, so which would be useful for MNRE. And it will be why, what is the reason for predictive models. Another thing very important is IEX. So IEX is going to be Indian Energy Exchange. We have given one model to IEX actually. So Indian Energy Exchange, who is Indian Energy Exchanges? They are going like how stock market is there. These IEX are going to fix the rate per kilowatt, how much rate. So they are going to fix the rate for the electricity, the energy produced in India, Indian Energy Exchange. So hence what happens here, they are more dependent on these predictive models. So you can think, okay, it is just like this. This is for publishing side. Okay, if you take it, it is for publishing side. Okay, let it be for publishing side. If you want to make patent out of it, yes, it is a software and AI model. You can develop it, you can use it, you can develop app, you can put it in your cloud, you can integrate it. So with all whatever computing is required, you can make it and you can make it as an app. Another part, yes, whom you are going to support. Yes, it can be a supportive if your prediction is accurate. Okay, so there will be plus or minus. See, all these AI models or ML model, I cannot tell, I will not tell. I have worked so much in this, I will not tell minus 100% accurate. Wherever I will tell, so first, you don't start directly with AI, ML or DL models. You first start with linear programming. Okay, I will tell my students, why you want, madam, I am very much interested in machine learning. No. First, you know what is linear programming. Okay, so then you start with non-linear. So let the data be a non-linear data. The data will have high uncertainties. Okay, I will show you some data as well. So the data will have so much uncertainties as well. So the uncertainties, the data has to be cleaned. Okay, cleaned or normalized or scaled, or like this process has to be done. So hence predictive models does not mean only intelligent predictive models or AI models or ML, but you can go in for linear programming techniques. Even a simple Gaussian method, okay, a simple Gaussian linearization can also help us for prediction with respect to the data which is being given. Okay, so hence, in all the cases, if you see, for example, so if you see ML models, so I think most of you will be what to say, will would have come across all this machine learning bar, neural networks bar, DL models as such. So to throw just a few minutes glimpse of what this ML is going to do. See, what is, so we leave a DL, okay? So we leave DL because we do not have all time to discuss everything. You remember, if data, if it is going to be time series data, if you are able to get time series data of any of your renewable sources, then you go for deep learning. If you are not able to get time series data, please do not apply DL models. Okay, you limit yourself to ML or you limit yourself to neural network models. This is my suggestion actually. But if you have time series data, don't go for all this. DL will work out in a very great way. Okay, so I am assuming you all have known the basics of all this machine learning and neural network models. I'll just let you know how here it can be applied. See, always machine learning. So if you see in NN models, you will have some process called training and testing. Okay, so training and testing. So what is the difference between an ML and a neural network model? So that is what. On the other hand, if you see ML, so if you see a neural network, it can be a regressor, it can be a predictor, it can be a associator, it can be a classifier. Here also, so an ML, so whether it is a linear regression, non-linear regression, but one of the most versatile which for working more than 2 decades. I will tell which is one of the good models. So whether it is a regressor or a predictor or a classifier. So even for classification, I will tell SVM, okay, support vector machines. So I have several papers work because I sometimes the result, if you see now, when you get the result, you will feel the josh of how that classification, how it is being done, you will get. So I suggest whoever interested to work, you can just explore support vector machines. So you can blindly please start working with SVMs if you have any access to any type of data. So if you see in this support vector machines, see always. So when predicting, okay, so I am telling predictive models. So predictive models for SVM. So SVM they will tell, okay, no, it is a better classifier. Can it be used for prediction? Yes, everything is presentation of the data. So if this falls within this hyperplane, for example, so it is called as a hyperspace. It will always called as a hyperplane. Okay, so a predicting hyperplane. Okay, so it will, you have to find this line, actually you have to find this line. Okay, so this line will be so you will have what to say, the data will be present on one side and this side, and the data will be on this side. Okay, so for example, if I want to predict which is site, so I have this wind speed, I have this humidity, I have this temperature, I will have this wind vane direction also. So you give all this data, you give all this data, you make some computation. See, I'm not talking about all this computation part, so because it's all fully some mathematical and involved. So here, if you see in SVMs, remember, if in predictive models, when we were working on these predictive models, we have worked with linear SVMs also, we have worked with non-linear SVMs also. So I have insisted my scholars to work on non-linear SVMs also, if because mostly all my data are non-linear, whether it is a solar data, whether it is going to be a what to say wind data, my data was a non-linear data. So hence non-linear data, if you see for example here only three data points, six, mine will be millions, ten thousands of data. Okay, thousands of data I can, so it is so much data will be there and so much non-linearity will be there in the given data. So hence always we have worked with all these non-linear streams, and these are called as kernels. Okay, so it will have some kernel functions. You have to choose appropriate kernel functions here. Remember, see, because the stock is very limited, I'm not telling what is a kernel, how to choose a kernel. There are some methods to create a even you can create a kernel. Okay, so like this, but here I'm telling it as a ready made. Okay, in SVM your data will be non-linear, hence you have to go for non-linear SVMs. Always your data will not be linear in nature, whether it is solar, wind, or even hydrogen data. So hence go for like this. So in non-linear you have to have something called as kernels. Ready-made kernels, if you see, there are some called Gaussian kernels are there, like universal kernel, Pearson universal PUKs are there, and if you see in another kernel, RBF kernels. Okay, so there are RBF kernels, so etc. So much kernels are there. So when you use for your prediction application, so when you use for your prediction application, so it is better, you will have an access to all this. So in machine learning, so in machine learning models, so I was suggesting you go with SVM. See, in SVMs, I told you linear, non-linear. So there are something called proximal support vector machines. So PSVM. There are multi-scale SVM, MS so much variants are there. Each one with the researchers being working in all the kernel functions and the learning mechanisms. So they have been into all these models. So this is so a predictive model which was one of the successful based on my experience in working. I'm telling SVM is one of the method. Now the going with respect to NN model. So I have used ML also. I have used NN also. We have used deep learning models also. So if you see in NNN, so the most versatile which I will be claiming based on my experiences, one of the versatile, see, these are all like 1948. If you see Minsky, Pepet, if you see all these people, so they have developed McClaw. If you see, McClaw has developed Hebb, so hence the name is Hebb, or Minsky. So he is an author who was very one of developing neural network. He was one of the forerunner. Okay, Minsky, Puppet, so etc. So many people were there. So if you see in this angle, so based on the experience, I will claim, some MTech students, I want to work for predictive models. For your some thesis, a small part of work, I want to do a course project. I have this subject, smart grid subjects, with renewable energy installation. So you can try all this. Okay, so one of the this is so BPN, another one is RBF. Okay, so I'm not going to tell the architecture of the neural network or the training of the neural network, supervised, unsupervised, or reinforcement, or the activation function. So I'm just giving you the glimpse of which are the networks which you can take and work on immediate basis. So whether you're doing the coding by Python, or whether you're going to do the coding in MATLAB environment, or you are going to work in C environment. So I worked in C, I worked in C++, I worked so much in MATLAB. Now that I'm working in Python also. So any environment is most suitable. Take the concepts, take the mechanisms. So in neural network model, I will tell it's one of the better results. Okay, so one of the better results has been achieved with respect to back propagation neural network models and radial basis function neural network models. So the difference between both this is the activation function which is being used. See, there are several mathematics. See, it is very important. See, these are all not like a black box tools. There are high mathematics behind ML models, mathematics behind neural network models. It's all a mathematical implication. So even if you take now the AI is ChatGPT. See, ChatGPT is going to be, it is generative transformer. If you see now full, if you see that last it is transformer. See, transformers are using so much calculation. So it will have something called key value. So that key value will be taken, and that key value will be taken. So it is a transformers. So now so it is the growing with respect to natural language processing. See, your ChatGPT version or ChatGPT Pro version, whatever you take. So it is dealing with natural language process. I am giving a natural language, how to develop predictive models. If I am giving, it has to search and it has to give answers. So I am writing it in a very natural language processing. So hence the sentiment analysis all have gone, and based on all these analysis only the transformers act. So behind the transformer there are so much mathematical base. So hence I'm telling, whether it is AI, ML, DL, or neural network model, so everything will have mathematical foundation. So if you see, for my predictive models, whether it is solar or wind. So I'm confirming you this gives better results. So one is a back propagation neural network model, and another one is a radial basis function neural network model. And the difference lies in the activation function, the usage of the activation function. So the learning rule, see, the most one of the versatile learning rule of neural network model is gradient descent learning rule, right? So in both the cases, you can use this gradient descent learning rule for both BPNN or going to be for RBFN model, and the activation function differs. So here it will be using something called sigmoidal activation function. If you see in RBF, versatile. Okay, so if you start using this, you will start loving it, how the Gaussian function operates. Okay, so always result analysis, they will tell always you make a bell curve or a normal distribution. So if you see this Gaussian function, right, so this will be a perfect one which will give the results. So hence you can go in for this type of RBFN model. So you will calculate the output, you will feed in all the cases, you will be feeding the input data with whatever data you have collected from your source. Okay, you can collect it directly even from a plant. Okay, renewable energy plant, some installations are there, you have friends, some resources you are, so you refer to my paper. If you want to ask me data, you can, maybe I can send you the data as well. So we have so much data data like that. So if you see, so please see, this is some of the data here. So this is one of the Windside data. So this was from April 6 to 31. Okay, so 2000 this was which is there. So if you see, so see the date and time and seconds. If you see, I'll just increase the visibility. View zoom. Yeah. So see here, this is going to be a wind speed. So meters per second, for example. Okay, so this is your anemometer reading. Okay, so if you see, so wind vane direction. So if you see, so for all, so the temperature in all these cases, if you see the temperatures are same. So it goes like this. So this is the data. If you see the data, so it goes to few entries. So this is for 1 year. Now though, or if you please go to NIW site, you have readily some data. Okay, so of Tamil Nadu district data, few data are available in their website, which is very high, because see, the wind power will be directly proportional to the wind speed. Okay, so the wind power, so with all the extra calculations and all the constant values, so what will happen is, so it will be like this. So if you have solar, I don't know whether I have hydrogen data. No, I don't think so. I don't know where I have the data. That hydrogen data actually. 1 minute, let me check. Yes. So this is, so see, so this is now that we have started working with this. There are not more papers with predictive models for hydrogen production as such. So if you see, so these are, so like cathode area, anode area, cell voltage. Okay, so cell current, power, water flow, hydrogen production. Okay, hydrogen flow, which is produced. With respect to that, what is going to be the hydrogen flow rate in terms of what is that? This milliliter per minute. Okay, so in liquid form. Okay, so what is the temperature? So this is with respect to the PEM, okay, PEM water electrolysis data sets. So these are the access to the data sets. Okay, so this is very difficult to get. Okay, so we have got this from Sharjah, but now though this Bharat Petroleum BPCL is having some plant in Cochin where they are producing hydrogen. So we are about to visit that BPCL plant at Cochin in order to get only the data, so that we can develop a predictive calculator or an app form for this hydrogen production application. So I want you to have a feed of the data. Okay, so solar, I don't think I'm having in this lab. Okay, so this is how our data will feel like basically. So if you see on the other hand, so here, let me explain it for a uh, for any model. Okay, so here the data cleaning will be there. I don't know, some mathematical foundation. Okay, let's leave this. Okay, so see here in MATLAB, I have imported this data. So if you see click data, so see, this is the data of the wind which I have shown here. So this wind data, right? If you see this wind data, so this 281.2 something, all this sort of thing. All this. So here you will have this data here. You have to predictive models. You have to follow the algorithm base, or you have to follow the what to say. You have to follow your base of your coding, whichever platform. It is not like you have to work only in this C or C++ or MATLAB. You can try to work in any platform, and you can just so data, you can input the data and you can just run. So you have to have your predictive model with minimized error. So like your actual data is there and your predictive data should be there, so your error should be zero. So matching that both your predictive model, so you have to train with millions of data, so that, and that's what I said, na, it will be like a calculator base. Just if you give this, you can get it. So if you see, so here it's long, I run this coding actually. So if you see error, okay, the R value is 0.9969. I think you can view it here. I want to see the error value. So the RMSC is 0.2906 here, and this mean square error is, this is quite high actually. It is 0.0844. We have to make it till 0.0006 as such, right? So you have to make it to that level, and here you have to have. So this is the error value. It was 0.0084. I don't know. Yeah, it is 0.0084 somewhere here, and this is comparison between the actuals and the predicted values. See, because it is 0.0844, I think we are not able to see the difference. Okay, so actual is continuous lines and the predicted is like this lines. So you should make an analysis. See the analysis, the error value, the output you get. Then again you have to make. See, you're if you're going to work like you are going to give it to what to say. You are going to 1 minute. Yeah, so it's here. So if you see, it is like yes. So the actuals and the predicted value. So you might not see because it is 0.0844. It is actually merging at few points, and few points it is not getting merged. But because since mostly like 95% of that gets merged, we are not able to see this actually. So here, so the slides will predictively say about all this. You can just Google for many like all this basics of all this neural networks, everything you can get it. So here, see, one of the important tasks when my scholar was working was fixing of hidden neurons was neural network was a very Herculean task, and she worked so much how to fix this neuron here. Okay, she has worked and her model was very successful, and she had some many mathematical foundations and carried out all these things. So and see, these are the parameters in the study. So which was collected from, this was not from NIWE, this was from Suzlon with wind power. So Suzlon gave us all the data. Okay, so you can also approach OEMs like that. So you can call like this. So and this is a general how we work for any application. So this will be a general flow. So this was the location was from this. What was the cut-in speed? What was the cutout speed? What was the height, temperatures, wind direction? So this was collected period. So even from for so it was actually collected from 2005 to 6, 6 to 7, 7 to 8, 8 to 9, and here it was run for 2011 to 12 as well. This was sample input data sets. So there are so much problems. I said you please go around the background and mathematical foundations of MLN models. So if you want to make a predictive model design, you should know how the data is represented. You have to select a proper network topology. You should analyze the network parameters. You should train the models. The predictive models has to be trained, and finally you should validate the model. See, everything is heuristic in nature. When I go for AI ChatGPT, you give each time you get a different answer. Which one will be? I will be validating it and taking it as a good answer. Okay. As since we are giving, we are humans, we are able to judge it is better. But statistical validation, so validations plays a major role. So when you are into development of predictive models, you should have validations of all this. So the training, all this foundation. So for each, I said, so she has worked on so much. I think this is not clear as such. So much, because so much data are there. So, and comparing with all the models, how you claim your model is best. There it was all tinted lines, you are not able to visualize properly when I run the graph. Here if you see, all these boxes are predicted and blue straight lines are actual, so you can confirm the predictive model follows the actual plans. So with the requirement of your renewable energy growth in India with respect to meet our power demand, 250 gigawatts and more amount of investments. Okay, so investments are huge with respect to wind installations or solar. If you want to generate 1 megawatt, it is going to be like nearly 4.5 crores investments is required. So hence all these predictive models will help you to get an idea, and you can, if you're really interested, continue working for all types of renewable energy, and you can be an expert giving advice to NIWE, NIWSE, or Indian Energy Exchange, like that. So I think, so I can conclude my talk here. So I'm open for any queries, my dear delegates. I think I've stopped sharing. Yeah. So if I want to teach completely ML, full neural, full DL, full all things, so it should be like workshops and full day or 2 days are required.
Ma'am,
Yes. Screen. Oh my God.
just a minute.
I think my mail ID will be in my website, so anyone can mail you if you're working with. See, I work on renewable energy. I work on few other models as well.
Yeah, ma'am. All right, ma'am. So, on behalf of everyone present here, I would like to extend my heartfelt thanks to you for joining us for such an elaborate keynote session. The real world examples and the practical insights on such critical sectors of renewable energy and association with predictive modeling truly depend on knowledge. Thank you, ma'am. Thank you so much.
Yeah, thank you. So at the outset, I would like to thank the entire organizing team of this conference, the institute, authorities of the institute for giving me an opportunity, and Dr. Sujit, who's always been in contact and facilitating me to be the keynote speech in this session.
Yeah.
So thank you, one and all. Thank you so much.
Yeah. Hello, ma'am. This is
Yeah.
Dr. Brain.
Yes, please.
After 15 years, ma'am, almost after 15 years, I'm hearing your lecture.
Oh,
So, student at NST Coimbatore.
wow, that's nearly nine.
Batch
Happy.
in the first batch student from NST Coimbatore. So I hope you
Oh.
know me. So I'm getting forward here. So
Uh-huh.
when the people suggested your name, so I was happy that I'm calling my teacher once again.
Wow,
Uh,
that's really, it's my pleasure. This is what is required as a teacher for being so long.
yeah,
I'm happy.
yeah. So thank you so much, ma'am. So it was a wonderful lecture.
Thank you
So
so much.
thank you so much.
Yeah, yeah.
Yeah, yeah.
Yeah. I think I should leave the meeting, right, Dr. Sujit?
Yeah, yes, ma'am.
Yeah, I can leave the meeting, right? Thank you.
Yeah, ma'am.
Yeah, thank you so much, guys.
Yes. He just okay. Right. We can end the meeting.
ಕಿರಣ ಕೇಳಿಸ್ತಿದಾ? ಲೈವಾ? ಹಲೋ, ಕೇಳಿಸ್ತಿದಾ? ಕಿರಣ ಕೇಳಿಸ್ತಿದಾ? ಹಲೋ ಕಿರಣ. Hello. ಮಾತಾಡ್ಸಲ್ಲ ಏನೋ ಮಾತಾಡ್ಲಿ ಸುಮ್ಮನೆ ಮಾತಾಡಂದ್ರೆ ಏನ್ ನಾನಾ ಮಾತಾಡ್ತಿದ್ದೀನಲ್ವಾ ಹೆಲೋ 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 ಎಷ್ಟೋ ಮಾತಾಡೋದು ಹೆಲೋ 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 ಕೇಳಿಸ್ತಿದ್ಯಾ ಸೊ ಜನಗಣಮನ ಅಧಿ ಜನಗಣ ಜನಗಣಮನ ಅಧಿನಾಯಕ
ಟೆಸ್ಟ್ ಮಾಡ್ತಿದ್ದಿಲ್ಲ ಅಷ್ಟೇ
Our chief guest, Mr. M.S. Bindu Madhava, Dr. Prem Kumar, Head of the Department, Electrical and Electronics Engineering, Dayanand Sagar College, Vice Principal first. On this note, I invite Akshaya to deliver a rendition. I now invite Dr. Manikanta Gopisetti, Coordinator of ICISPS.
No, drag ಮಾಡಪ್ಪ. Start ಮಾಡ್ಬಿಟ್ರೆ.
Thank you, Dr. Manikanta. Your words have set the tone for this significant occasion, reflecting the purpose and vision of the international conference.
ಬರ್ತೈತೆ ತಾನೆ?
I now invite Dr. Sumavi, the Vice Principal and the Head of Department for Computer Science. I now kindly request Dr. Sumavi, the Vice Principal and Head of Department, Computer Science and Design Engineering, Dayanand Sagar College of Engineering, to felicitate Mr. M.S. Bindu Madhava, our chief guest for today. Thank you, Dr. Sumavi. I now call upon Dr. Prem Kumar, Head of Department, Electrical and Electronics. To felicitate Dr. Sumavi, the Vice Principal and Head of Department for Computer Science and Design Engineering, Sagar College of Engineering. I further request Dr. Prem Kumar to felicitate Dr. Sujit Kumar, Coordinator for ICISPES-2024. I request Dr. Usha P, Coordinator of ICISPES-24, to felicitate Dr. G. Manikanta, Coordinator for ICISPES-24. Ma'am?
This one is a safe also.
Body. I, Gauri Srinivas, am honored and privileged to extend a warm welcome to the valedictory session of the second International Conference on Sustainable and Efficient Power Systems. Over the past few sessions, we have had the remarkable opportunity to gather as a global community to exchange knowledge, explore innovative ideas, and discuss groundbreaking research that holds the potential to shape the future of sustainable energy systems. This conference has been a testament to the collaborative spirit that drives progress in addressing the complex challenges of energy sustainability, efficiency, and resilience. From thought-provoking keynote addresses to dynamic technical sessions and inspiring discussions, the insights shared here have illuminated new pathways for achieving a greener and more efficient power infrastructure. This year's conference offers a vibrant exchange of ideas through keynote addresses, technical sessions, panel discussions, and industry exhibits, creating opportunities for collaboration and innovation. On this note, could we please have the video presentation of ICISPES 2024? Thank you. I now invite our esteemed dignitaries onto the dais. Our chief guest, Mr. M.S. Bindu Madhava, Dr. Suma V, Vice Principal and Head of Department, Computer Science and Design Engineering, Dayanand Sagar College of Engineering, Dr. Prem Kumar, Head of Department, Electrical and Electronics Engineering, Dayanand Sagar College of Engineering, Coordinator for ICISPES 2024, Dr. Usha P, Coordinator for ICISPES 2024, Dr. Sujit Kumar, Coordinator for ICISPES 2024, Dr. G. Manikanta, onto the dais. These distinguished individuals are visionaries and thought leaders who have dedicated themselves to advancing sustainable energy solutions and inspiring positive change in the global energy landscape. On this note, I invite Akshaya to deliver a rendition of a prayer song. Shri Raghavam Dasharathatmaja Maprameyan Sitapatim Raghukulanvaya Ratnadipam Ajanubahum Aravinda Dalayatakshan Ramam Nishachara Vinashakaram Namami 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 Shri Raghunandana Dasharatha Nandana Shri Raghunandana Dasharatha Nandana Bhadradishwara Rama
विश्वेश्वर रामा वैदेही
Thank you, Akshaya. I now invite Dr. G. Manikanta, Coordinator of ICISPES-2024, for the welcome address.
Good afternoon, all respected dignitaries, distinguished guests, esteemed speakers, fellow colleagues, and dear participants. It is my honor and privilege to welcome you all to the validity session of Second International Conference on Intelligent and Sustainable Power and Energy Systems. On behalf of Department of Electrical and Electronics Engineering, DSCE, and all the participants of ICISPES 2024, it is my privilege to welcome the chief guest of today's valedictory session, Mr. B.S. Bindumadava, Center Head, Power Grid Center of Excellence in Cybersecurity, IISc. It is my pleasure to welcome guest of honor, our beloved Vice Principal Dr. Suma V, on behalf of Department of EEE and all participants of ICISPES 2024. Welcome, ma'am. I would like to welcome Dr. Prem Kumar M, HOD, EEE. I welcome coordinators of ICISPES, Dr. P. Usha and Dr. Sujit Kumar. I extend my warm welcome to all the heads of the department, DSCE, faculty members and students of EEE, and all the participants of ICISPES. On behalf of Department of EEE, I would like to thank the management, Secretary Sri Galiswamy, Principal Dr. B.G. Prasad, and Vice Principals for their unwavering support and encouragement. Over the past few days, we have witnessed an enriching exchange of ideas, groundbreaking research, and innovative solutions in the field of power and energy systems, all aimed at achieving a sustainable future. This conference has brought together a diverse group of scholars, researchers, industry professionals, and students from across the globe. United by shared commitment to address the challenges of sustainability through intelligence-driven solutions, your active participation has been instrumental in making this event a grand success. As we gather here for the concluding session, let us reflect on the insightful discussion and fruitful collaboration that has taken place during the conference. From the keynote speeches to the technical sessions and panel discussions, every moment has contributed to deepening our understanding and inspiring new directions in research and development. I extend my heartfelt gratitude to all the speakers for sharing their expertise, the organizing committee for their tireless effort, and our sponsors and collaborators for their unwavering support. To all the participants, your enthusiasm and engagement has been the lifeblood of this event, and we deeply appreciate your contribution. As we conclude this conference, let us take the knowledge and idea shared here as a stepping stone to future innovation and advances. May the network we have built and the insights we have gained continue to shape a sustainable and intelligent future for energy sector. Once again, I thank all your presence and contributions. I hope you found this conference as rewarding, as inspiring as we intended it to be. Wishing everyone safe travel and continued success in your endeavors. Thank you one and all.
Thank you, Dr. Manikanta. Your words have set the tone for this significant occasion, reflecting the purpose and vision of ICISPES 2024. I now invite Dr. Sumavi, the Principal and the Head of Department, Computer Science and Design Engineering, Dayananda College of Engineering, to address the gathering.
Good evening. Good evening to one and all. It's real privilege and a great honor for me because I'm just seated next to the most potential and highly intellectual personality, Bindu Madhav sir. Undoubtedly a personality whom we actually, for me, I was just talking to Dr. Prem Kumar. He's a fatherly person. So thank you so much, sir, for accepting once again the invitation to Dayanand Sagar. It was almost few years back that we had a few years back he had come. So couple of incidents had invited him, but he could not come. But I'm feeling very jealous that he came to this event. But that's on a lighter note. He's a personality whom, if you listen to his words, will take you miles and miles ahead to excel in your life and in your career. Once again, congratulations to the entire team of the Department of Electrical and Electronics Engineering with the leadership of Dr. Prem Kumar and Dr. Usha, and I just could hear the few words of Dr. Manikanta, and all the coordinators, student volunteers, participants of this event. As we were discussing just now, that this is a conference where sir will talk more about it, Bindu Madhav sir will address more on that. This is actually a reflection of 5+0 industry, where we were talking about industry 4.0. He says now we are far ahead and the title goes intelligence and smart. That means today we are not going for a world which is a hard-working world, but today we are also not in a world which is a smart world. We have rather stepped inside a world which is intelligent. The world is so intelligent that any electronic gadgets, any devices can do what a human can do. It's a cobalt applications that we are developing. We go for co-creation of projects with cobots. This is what we are currently prevailing in. So for that, there's a lot of technology-driven knowledge that needs to be acquired, which cannot happen by ourselves unless we make ourselves present, witness, and imbibe the knowledge which is shared in forums like this, international conference forums like this, where many researchers, many ideas will just flow like waves in the ocean, one after the other. Paper, when you present, it's like one wave and then another wave. How many of those waves will really hit the sky? We do not know. So I always feel that an international conference is an arena where we can acquire tremendous knowledge, and this knowledge we can culminate into products, innovations, innovative products rather, and make our India a better place to live. And we have to, with all these words, I think I don't have to take too much of time because sir is there. His words are so precious and wise. So with this note, I would like to congratulate once again all the participants, and whosoever ideas, if they are really good with the leadership team of the conference, I will request them to submit it for patent filing. Let's see how much we can proceed with the patents, publishing, grants, And if any of ideas and books, research works are really true good, innovative in nature, it can be supported either through Derby foundations or through NISP or even seed money of the institutions. We will take it forward because our motto, our vision is to see that we are contributing to this contemporary society through the knowledge that we have. So with these few words, once again congratulating entire team, thanking Bindu Madhav sir for being here. I wish you all the best. God bless you all. Take care. Jai Hind, Jai Karnataka.
Thank you, Dr. Sumavi, for your insightful and encouraging words. We deeply appreciate your time and effort in being here and for sharing your thoughts, which will undoubtedly resonate with everyone present here. Mr. B.S. Bindu Madhava is a Senior Director at the Center for Development of Advanced Computing in Bengaluru, India, where he leads the Real-Time Systems and Smart Grid Group. With approximately 29 years of experience in the industry and information technology sectors, he has made significant contributions to the field. He holds a bachelor's degree in electrical and electronics engineering from Bangalore University, a postgraduate diploma in the systems management from NIIT, and an MS in electronics and controls from BITS Pilani. His research interests include network and internet security, real-time systems, agent computing, smart grids, self-managing system software, and cyber-physical systems for security. He has authored over 35 papers presented at the international and national conferences. Mr. Bindu Madhava is a fellow of the Institution of Engineers, a senior member and the past chairman of IEEE Computer Society Bangalore, and has held leadership roles in the Computer Society of India Bangalore chapter and the Advanced Computing and Communication Society. He is also a member of the Association for Computing Machinery and the Internet Society. I now invite our chief guest, Mr. M.S. Bindu Madhava, onto the dais to address the gathering.
So good evening. First of all, I congratulate the electrical department to take up this particular conference, which is very apt in this today's scenario. And I would also thank the Vice Principal, Suma, for being here. And she told me I was a little jealous of me being here. One thing. Second thing is the introduction was good because I was taken 10 years back. My experience is 39 years and I am retired from CDAC. And I've been heading a center which is funded by PowerGrid Corporation of India, which is a center of excellence. We do research in cybersecurity in the operational technology domain. We don't look at IT space. So we look only at the critical infrastructure security. This is one thing input I just wanted to give. Basically, I was here for another thing because one thing, I don't have a membership of PES from IEEE, but I'm from Computer Society membership base of IEEE. But my basic engineering is electrical. So that's why I'm here. So there was an invite from electrical department. So I thought, okay, I should be here and sort of, I've come to this institution many a time, minus electrical department inviting me here. So this was the first opportunity. I thought, okay, let me sort of come and see what is the thing happening. Coming to this particular topic, I was just trying to see how apt this is, because I was seeing generally the theme of the conference is coined well, so that we get a number of people, good number of papers. But the focus can be lost. So that is one input I just wanted to try to have conferences which has got a deep dive technology into the thing, which gives a lot of input for our own faculty Second thing is the students. You will be inspiring the students to get into this higher education, that is doing their masters as well as PhD. So that is the one thing what we'll be setting up. So I was trying to see what inputs I can give, because generally being a technical person and being there in this particular space for a very long time, and this theme has come up. So I was trying to see what inputs I can give. I just inferred from this, whatever the title of the thing is, you are trying to sort of meet the sustainable development goals of which has been set by UN. There are totally 17 of them. So I think this we are trying to address the seventh goal, which is affordable and clean energy. So my input is basically if you are able to sort of come out with any technologies which can leave smaller footprints of carbon. So that becomes very important as a technologist for the contribution, because the net zero, whatever we are talking about, which we are trying to address and get by 2030, is what we are to be sort of contributing to this. So the next thing what I just wanted to sort of give an input for the electrical people and PES is try to have conference on energy security, because that is the space where we might have to look into the futuristic thing. That of course the technology, whatever Dr. Suma told, Industry 4.0 is forgotten. So we are trying to look at Industry 5.0 and plus. That's what I had, is what we are trying to do. So I think we should be able to mix and match these things, but come out with an index of measurement. Whom are we doing this, all these things? What are the development goals we are trying to achieve? So we might have to ask these questions every time whenever we do some sort of activities like this. So we should be able to, there is a ranking which has been given for all the countries based on the sustainable development goals, which is the thing which has been set, and against that what has been achieved. Not only for the countries, even the states of India also has been measured on this particular basis. So I think going ahead, we should say the educational institutions, their contribution to sustainable development goal, what is that they're trying to do? Whether do you have a clean campus? Okay, it starts from there. So how much of the clean campus is there, and how much of the contribution of the clean campus you are doing for the state? So it starts from that particular thing and taking it forward. So I think next version, I was told Dr. Prem is trying to sort of come out with the next version of the conference. I suggest that you have a theme, energy security, as a theme, and try to sort of bring out the indexes from the campus side itself, how much of contribution you are making to the state, and that can be taken forward to the rest of the things. So this is one input I just wanted to give. And of course, energy security, you can Google. So it says and gets connected to HDG 7, that is clean energy and sustainable, this one. And try to connect with another SDG, which is talking about technology. So connect these two and try to derive a matrix. So you should be able to sort of publish this particular information saying that this is our contribution. So that gives a good, this one for the institution, as well as people will be thinking that you are looking at overall development of the thing. It's not only education or research, but you are trying to sort of contribute in these particular areas of the sustainable goal developments. So with this things, I think I was told to talk only 5 minutes, so I thought not more than this particular thing. Of course, now with the current avatar, I do a lot of development of or look into the research problems which are there in cybersecurity in critical infrastructure. So if some student is interested, we can sort of look into the internship place where people can come and do the internship at my center, which I had. So with this few words, I thank the management of Dayananda Sagar College of Engineering, for giving me this opportunity to be here and say a few words. Thank you.
Thank you, Mr. M.S. Bindumagava. We are deeply grateful for the time you've taken to share your expertise, insights, and perspectives with us today. I now invite Dr. Usha P., Coordinator of ICISPES 2024, to the dais to address the gathering with a summary conference report.
Good evening to one and all present here. I welcome you all to this last session of our two-day international conference of intelligent and sustainable power and energy systems. It is my pleasure and privilege to present the conference report. This summary aims to encapsulate the essence of our gathering, showcasing the key themes, thought-provoking discussions, and the wealth of knowledge we have shared. This conference, Intelligent and Sustainable Power and Energy Systems, is an annual conference series began in 2023, and this marks its second edition. The series is set to continue in the future as well. This has been conducted in hybrid mode. Our preparation for this conference started in the month of March 2024 with support and encouragement of our college management and guidance from our beloved principal, Dr. B.G. Prasad. The conference focused on the topics such as energy storage systems, intelligent control and automation, AI and ML techniques for sustainable technologies, IoT for sustainable development, smart grids, microgrids, nanogrids, power quality, electric and hybrid vehicles, renewable and sustainable energy, sustainability for manufacturing, machine learning for manufacturing and biomedical applications, and etc. Our technical partners for this conference are IEEE Power and Energy Society, Institution of Engineers India IEI, IEEE Power Electronics Society, and IEEE Industrial Application Society. Our industry partners are LogicZap and Snetly. LogicZap is a leading company for electric vehicles, robotics, and IoT applications. Snetly is a real-time model-based development platform. Our publication partners are Tyler and Francis Groups, Cypress, and STM Journals. The first call for papers was made on 30th August 2024. We started receiving the papers from the very beginning. The reviewers panel was formed with 140 professors and associate professors from India and abroad to conduct a single blind review process. We have received approximately 250 papers across India, and we have received from almost all states of India, that is Himachal Pradesh, Tamil Nadu, Andhra Pradesh, Goa, West Bengal, Assam, Jammu and Kashmir, Maharashtra, Rajasthan, Uttar Pradesh, Odisha, and Kerala. And from outside India, we have received from Japan, Nigeria, South Africa, Vietnam, and Bahrain. Out of the 250 papers, a few were rejected due to high level of plagiarism. And for the remaining papers, each paper was reviewed by 2 reviewers, and finally 90 papers were accepted for presentation. These papers have been categorized for various publication groups based on the reviewers' recommendation and authors' inputs. We are forwarding 35 papers to Tyler and Francis, that is Scopus Indexed Conference Proceedings, 26 papers to Cypress Proceedings, and 27 papers to Google Scholar Indexed STM journals for potential publication. Regarding the participants and registrations, We were honored to have participants from across India and from outside India, each contributing their unique backgrounds, professions, and perspectives. This diversity significantly enriched our discussions and highlighted the global relevance of the topics we addressed. And the chief guests for the conference were our esteemed guest for the inaugural function of the conference were Dr. Gopal Hegde, Professor, Indian Institute of Science, Bangalore, and the guest of honor was Dr. S. Albert Alexander, Associate Professor, Vellore Institute of Technology, Vellore. Along with them, our college secretary, Mr. Galiswamy, Vice Principal, Dr. Ramaraju, and Vice President, Placements and Skill Development Center, DSE, Mr. Guru Venkatesh, were present. For this valedictory function, we are fortunate to have our chief guest, Mr. B.S. Bindu Madhava, Center Head, Power Grid Center of Excellence in Cyber Security, and Vice Principal, Dr. Sumavi. Regarding keynote sessions, we hosted 4 keynote sessions. We were privileged to have 4 keynote speakers, each highly esteemed and widely recognized for their significant contributions to research in their respective fields. And they are Professor Yang Siasan, she is Associate Professor, University of Johannesburg, South Africa. She has delivered a talk on evolutionary optimization algorithms and renewable energy systems. And the next speaker was Dr. Gwangyil Jeon. He is a professor at Incheon National University, Incheon, Korea. The title of his talk was Application of AI-based Computer Vision Technology in SMEs. Dr. S. Albert Alexander is the third speaker. He is working as an associate professor, grade 2 in the School of Electrical Engineering, Vellore Institute of Technology, Vellore. His talk was on applications of machine learning techniques for the performance improvement of power electronics and drives. And the fourth speaker was Dr. S.N. Deepa. She is an associate professor in the Department of Electrical Engineering at National Institute of Technology, Calicut. She has delivered a talk on predictive models for renewable energy applications. Regarding the sessions, the core of this conference was the diverse array of sessions, presentations covering a wide range of topics. There were a total of 12 sessions, each selecting a best paper. Each session was chaired by 2 experts. Both the members were external members, and for few sessions, one external and one internal member was there. About the collaborations and partnerships, this event provided an excellent platform for networking and collaboration. Many participants discussed about potential partnerships and projects aimed at addressing real-world challenges. The impact of this conference extends beyond its conclusion. We encourage participants to carry forward the knowledge, connections, and inspiration gained here to drive positive change in their respective fields. Before concluding, I extend my heartfelt gratitude to the organizing team, convener, coordinators, and all the committee members, volunteers, sponsors, and everyone who worked tirelessly to make this conference a success. Your dedication is truly commendable. In closing, I want to emphasize the significant impact of this conference. It was a collective effort to enhance knowledge, promote collaboration, and address challenges. As we leave this venue, let us carry forward the spirit of innovation and cooperation that defined our time here, knowing that our contributions can make a difference in the world. Thank you.
Thank you, Dr. Usha. Your meticulous recap of the sessions, key discussions, and takeaways has provided us with a clear and cohesive understanding of the wealth of knowledge shared during this event. Without further ado, let us now proceed towards the awards. I request Chief Guest Mr. M.S. Bindu Madhava to hand over the Best Paper Awards. Starting off with the Einstein session, the best paper goes to Comparative Study of Non-Isolated DC-DC Converters for Fuel Cell Electric Vehicles by Shilpa Acharya. Shilpa Acharya, please proceed towards the stage. From the Franklin session, we have MATLAB-based graphical user interface for parameter computation of Type 2 and Type 3 controllers for DC-DC converters, presented by Karthik M. Rao. From the C.V. Raman session, we have photovoltaic-based charging of 5-volt smart gadgets in Indian household by Suraj S. From the Charles Darwin session, we have the paper EcoBot, Autonomous Trash Collection and Segregation System by Harshita M. For the Faraday session, we have sign language enabled offline IP-based video call intercom system for the deaf, presented by Prakriti Bajpai. For the Galileo session, we have parameter optimization of PID controller utilized for speed control of DC motor and Ziegler-Nichols and Cohen-Kuhn tuning method, presented by Anmol Mishra. For the lenses session, we have the paper single axis sun tracker for PV panels using a single slit sun sensor by Vishwa Shah. For the Newton session, we have real-time automobile-caused air pollution monitoring system by Maulya M. For the Ramanujan session, we have comparative study of ORB SLAM 2 and IR-based revolution counting with ultrasonic obstacle avoidance for autonomous wheelchair navigation by Giri Prashant P. For the Stephen Hawking session, we have the paper A Wireless Power Transfer System Calibrated for Multiple Loads by C. Varun. For the Tesla session, we have Mobile Electric Vehicle Charger with Fast Charging Technique by Rakshit Ramesh Nayak. And for the Thomas session, we have the paper Optimal Allocation of Distribution Generators in Distribution System with Various Load Models, presented by Babita Gupta. I thank our chief guest for doing the honors, and now I would like to call upon our Vice Principal and the HOD of the Computer Science and Designing Department, Dr. Suma V, to present the participation awards. Starting off, we have paper ID 93, Sri Lakshmi P. Okay. Paper ID 110, Nimisha T. Paper ID 173, Karthik M. Rao. Paper ID 147, Gautam C. Paper ID 164, Yuvraj H. Paper ID 170, Anjali K. Paper ID 148, Avneet Shankar. Paper ID 186, Umar Farooq BM. Paper ID 170, Dr. Jagdish N. Dr. Jagdish N, apologies. Paper ID 128, Harshavardhan S. Paper ID 145, Prakriti Bajpai. Paper ID 39, Janvi Prabhu. Paper ID 149, Supriya Nayak. Paper ID 141, Nikhilesh Singh. Paper ID 170, Dakshayani S. Paper ID 170, along with Dakshayani, we have Lalita and Lakshmita N. Paper ID 145, we have Nikita Singh. Paper ID 145, again, we have Ravi Shankar Kumar. Paper ID 39, we have Amulya U. Reddy. Paper ID 151, we have Abdul Adnan. Paper ID 159, we have P. Apurva. Paper ID 150, Sumukh MS. Paper ID 139, P. Karthik. Paper ID 179, C. Varun. Paper ID 181, B. Sandeep Reddy. Paper ID 175, Yashaswini N. Paper ID 158, Maulya. Paper ID 174, Rakshit Ramesh Nayak. Paper ID 144, Prabhakar Rai. Paper ID 163, Shreyas S. Anchan. Paper ID 168, Kiran Kumar Palid. And the last one, paper ID 180, Tanushri HT. Now for the faculty papers, we have Dr. Anubhav Kumar Pandey with paper ID 160. We have paper ID 170, Dr. Jagdisha N. Paper ID 160, Dr. Nandini KK. Thank you so much, Dr. Sumavi. I would now like to request Dr. Prem Kumar, Head of Department Electrical and Electronics Engineering, to present the volunteer awards. Volunteer certifications. The first one going to Website, Brochure and Poster Development Committee. Can we please have the committee on stage? Students and faculty, please come on the stage to receive your certifications. The sponsorship and the marketing committee, students and faculty, please be present on stage. The Finance Affair Committee, students and faculty, please proceed to the stage. The Review, News, Media and Photography Committee, please proceed to the stage. Faculty and student. The Registration, Declaration, Stage and Certification Committee, please proceed to the stage. Faculty and students. The Food, Refreshments and Hospitality Committee, faculty and students, please proceed to the stage. The Technical and the Participation Committee, faculty and students, please proceed to the stage. Last but not the least, the Publication Committee, faculty and students, please proceed to the stage. Marketing and sponsorship. I request everyone to settle down, audience. Coordinators and faculty, please settle down. I now kindly request Dr. Sumavi, the Vice Principal and Head of Department for Computer Science and Design Engineering, Dayananda College of Engineering, to felicitate Mr. M.S. Bindu Madhava, our Chief Guest for today. I request Dr. Prem Kumar, the Head of Department for Electrical and Electronics Engineering, Dayanand Sagar College of Engineering, to felicitate Dr. Sumavi, the Vice Principal and Head of Department, Computer Science and Design Engineering, Dayanand Sagar College of Engineering. I further request Dr. Prem Kumar to felicitate Dr. Sujit Kumar, Coordinator for ICISPES-2024. I request Dr. Ushafi, Coordinator for ICISPS 2024, to felicitate Dr. G. Manikanta, Coordinator for ICISPS 2024. Thank you, dignitaries. I now invite the Head of the Department of Electrical and Electronics Engineering, Dayanand Sagar College of Engineering, Dr. Prem Kumar, to deliver the vote of thanks.
Yes, so ladies and gentlemen, good evening. So I'll take quite almost for some 5-10 minutes because the list is huge. So I just want to thank each and every one. So please don't mind. So if I take some more time. So as we stand at the conclusion of the second international conference on intelligent and sustainable power and energy system, ICISPES 2024, it's a moment of self-examination, gratitude, and renewed commitment. First and foremost, I thank the Almighty God for blessing us with the wisdom, strength, and resources to conduct this conference successfully. So the compassion has been our guiding light in ensuring the smooth progression of the events and the success of our endeavors. So before we begin, I would like to thank the management. I sincerely thank our chairman, Dr. Hemachandra Sagar, Vice Chairman, Dr. Premachandra Sagar, and Joint Secretaries, Ms. Tintisha H. Sagar, Mr. Rohan H. Sagar, Mr. Nishan H. Sagar, and Ms. Natasha H. Sagar for their guidance, encouragement, budget allocation, and facilities which form the cornerstone of all our endeavors. I would also like to thank our respected principal, Dr. B.G. Prasad, whose leadership and support to fostering a culture of research and innovation. So, sir, while you are unable to join us today, so your leadership has been pivotal to the successful organization of the conference. I would like to recall the inauguration of our conference, where the presence of our distinguished chief guest, Dr. Gopal Hegde, the professor from Indian Institute of Science, Bangalore, the guest of honor and the keynote speaker, Dr. Albert Alexanderes, a professor from VIT University, Vellore, graced us. Their insights and blessings set the tone for the enlightening sessions that followed. I would like to thank our Honorable Secretary, Sri Gauliswamy, has been bedrock upon which this conference was built. His dedication, foresight, and commitment have shaped the event, ensuring its success and relevance. I would like to thank Dr. H.K. Ramaraju, our dynamic Vice Principal and Head of Civil Department, who has always been a pillar of support and guidance. Today, we are honored to have Mr. B.S. Bindu Madhava, the Center Head of Power Grid Center of Excellence at IIC Bangalore, as the chief guest for our valedictory function. Sir, your inspiring words have truly enriched us and left a lasting impression. So, very big thank you to you for joining this occasion, sir. And also we honor to have Dr. V. Suma, Vice Principal and Head of the Computer Science and Design Engineering Department, the Answer College of Engineering, as the guest of honor for valedictory function. So we are very privileged to have you here, ma'am. So thank you for joining here. Yeah. I would also like to extend my heartfelt gratitude to our vice principals, Dr. H.K. Ramaraju, Dr. V. Suma, and Dr. Ramesh Babu, for their steadfast support and guidance. I also wish to express my sincere thanks to our deans, Dr. Annapurna Patel, Dr. Ashwat, Dr. Shobha, and Dr. Sriram, for your invaluable contributions to academic and research excellence. So my sincere thanks to all the keynote speakers. So as you all know, so we had four keynote lectures. So the first lecture was given by the Dr. Albert Alexander, and the second lecture was given by Dr. Wangal Jan, and the third lecture was given by Dr. Zanzio San and Dr. Sandeepa. So we are very thankful to the keynote speakers. So they have given a wonderful insights and some inputs to all the researchers who have gathered here. So they can start doing research from the inputs what they have given. And also the session chairs. So we have invited more than 15 external session chairs and few internal session chairs. So I would like to thank each and every session chairs, whether you are internal or external. So thanks for joining us. So your involvement here, it enriched our conference. So thank you for joining as a session chair today. So the essence of our conference lies in the quality of its content. For this, we all heartfelt gratitude to the reviewers. As we told you already, we have invited more than 200 reviewers from all around the world, and the people have voluntarily contributed, and they have given a wonderful review comments. So that those review comments was very useful for the authors to improve the quality of the papers. We are very thankful to all the reviewers. And a big thank you to all the delegates and authors who presented their research, participated in discussions, and enriched the conference with their innovative ideas. Your active participation, insightful discussions, and collaborative spirit have been the cornerstone of this conference, and your contribution enriched our event. So thank you so much, all the delegates who are the internal or the external. So the people have traveled from very long also. So thank you very much for joining this conference. To our industry partners, Mr. Shahjahan, the founder Snedley, and Mr. Kunal, founder LogicZap NextGen Technologies, and the publication partners, Taylor and Francis, Cypress, and STM Journals, and the professional societies such as IEEES, IEEE-PELS, IEEE IAS, and IEI. So thank you for your support and collaboration, which has elevated the quality and impact of this event. Your involvement ensures that this conference remains a bridge between the academia and industry addressing a real world challenge. So thank you so much, all the sponsors. I would also like to thank my deepest gratitude to our faculty members, non-teaching staffs, and student volunteers whose hard work, dedication, and teamwork have been backbone for this conference. To my faculty members and non-teaching staffs, your unwavering commitment to the excellence and your ability to go above and beyond your regular responsibilities, as I understand that, so the people are involved in NBA process, NIRF process, NAC, and including this conference. So your tireless efforts and it's mind blowing. So thank you for us. Thank you to you people. Your involvement, it's really, I'm very proud to lead such a remarkable team. So thank you so much to all the faculty members and the non-teaching staffs. To our student volunteers, I want to say that you are the true energy behind this event. So this time, I just told the coordinators, this time the complete event should be taken care by the students. So it happened. So it's because of our students' energy. It's really happened. I thank each and every student involved in this process. Yes, so special thanks to the conference coordinators, Dr. Usha, Dr. Sujit Kumar, and Dr. Manikanta for your meticulous planning and execution. Yes, so before I say, you just applauded, so because it was there in my script. So thank you so much for applauding the student volunteers as well as the faculty and the coordinators. So thank you once again. Yeah. So I would like to extend our heartfelt gratitude to the faculty members of other departments who are indirectly involved here and the heads of various departments. Okay, your presence and unwavering support have been invaluable. I convey my heartfelt thanks to the facilities, accounts, the EDP team, and the supporting staff. Their behind scenes work ensured a smooth and memorable experience for all the attendees. Thank you. I thank the present media who played a crucial role in spotlighting the significance of our discussion finding. So before we conclude, like last year, I am thrilled to announce that this conference series will continue and soon we will launch ICISPS 2025. So please mark your calendars for we shall meet again to further share our mission. If there is anyone I may have unintentionally missed, so please know that every effort, big or small, has contributed immensely to success of this conference. In conclusion, let's carry forward the momentum gained here and work collaboratively towards a sustainable future in power and energy systems. We look forward to many more such collaborations and wish you all success in your endeavors. So thank you, and until we meet again, have a safe journey. Thank you all.
Thank you, Dr. Prem Kumar, for delivering such a heartfelt and well-articulated vote of thanks. Your thoughtful acknowledgements and expressions of gratitude have perfectly captured the spirit of this event and recognize the efforts of everyone who contributed to its success. I now request everyone to please rise for the national anthem.
पंजाब सिंध गुजरात मराठा द्राविड़ उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जनगण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय जय जय
Thank you, everyone. Our dignitaries will now be led out by the coordinators. All students, coordinators, and faculty members are requested to be seated because we will have group photographs. Participants, I told faculty. If the participants as well, please be present here. Do not leave the premises. All the faculty coordinators of various committees, please proceed to the stage. All faculty members, please proceed to the stage. Student volunteers, please do not move. You all will be also accounted for, so do not leave the premises.